Hello everyone, today I'll be talking about my reinforcement learning based autonomous racer. I call it ACAI, stands for ASSETTO Corsa Artificial Intelligence, and my name is Archer Cullen. So let's get right into it. We'll first talk about the introduction. So the goals here is to use reinforcement learning algorithms and methods and frameworks to create an autonomous racer that could complete a lap of Daytona optimizing for a fast line and ideally beat the inbuilt AI. The car we'll be using is a Lotus 125. Has plenty of downforce because it's modeled after an older F1 car, a lower series spec car. So it has a little less power, but it still has plenty of downforce. So control really isn't a problem. So why would I want to do something like this? Currently, race teams employ sim drivers to optimize car setups and get feedback about different setups, how they feel, etc., and if they're quick or not. And an autonomous racer could cut out a lot of the work that's required and a lot of the time, just because, A, it's automated, so you don't really need to do too much, and you could use vectorized environments, find lap time out of different setups of the car, and that really helps the testing process of different parts, etc. And then lastly, you could also determine if a setup is too hard or too finicky to drive or doesn't interact well, just because you could analyze the inputs and you could determine if that's too extreme or something too difficult for the drivers to handle. So the environment I'll be using to create this is it's a game called ASSETTO Corsa, and it includes a lot of different factors that goes into the car simulation and control. For example, you have dynamic suspension, weight transfer, tire heating, and loading characteristics that affects grip. Aerodynamic simulation also affects grip and how the car handles. You have fuel consumption and tire consumption that affects the weight balances of the car, how much grip, etc. ASSETTO Corsa is actually used as a base package for Scuderia Ferrari that they use in their simulators at their factory when they're developing F1 cars, so I thought that was pretty cool. Compared to more conventional environments such as Carla, the ASSETTO Corsa fell more in line of our goals, which is to go fast around a racetrack. And lastly, it's a very extensible environment to some degree. Python is a main language used for a lot of the apps, so you could get a lot of data out of the simulation and use that elsewhere. So let's talk about the method here. So first, let's just talk about how it's all set up in the architecture. So we have our game off here to the left. We are taking the speed, position, and a whole host of other things I won't go into. And we're putting that into a memory mapped JSON file that's then being read by our OpenAI GYM environment wrapper. And here we're calculating rewards per state, and it's also executing actions that gets output from our reinforcement learning algorithms via a controller, a virtual controller. And it also is able to detect reset states such as hit walls, or you've cut into the grass, or you've cut a corner, etc. And lastly, where most of the heavy lifting is done is in Stable Baselines 3, which is the reinforcement learning framework that I've chose to use, and RLZoo. Basically, Stable Baseline 3 offers the implementations for state-of-the-art algorithms, and RLZoo offers the training framework and the training loops to get all that stuff trained. Also offers a ton of hyperparameters. And currently I'll be using actor critic-based algorithms, which I'll get to soon. Here's just an example of what it looks like in the simulation. I apologize if it's hard to see the lines here, but the purple line in the middle is basically the geometric ideal line around a track. They call it the ideal line, however, car characteristics really goes into the ideal line, so this is more of a geometric ideal line. The red line off to the left is obviously track limits, don't cross the double yellow. And then obviously you have your wall to the right, and there's also a red line over there, just to emphasize don't go there. This blue line we could ignore, it's really just how to get into the pits, and it's just inbuilt part of the game. So let's talk about actor-critic-based algorithms. So it's split into two main parts. We have our actor network and our critic network. And the actor network is pretty simple. It's just responsible for selecting actions based on a state. Meanwhile, the critic network evaluates the actions chosen by the actor network, and it really just basically says, hey, this action was good, or this action's bad, determines the values. and then they train in conjunction with each other. So the two actor critic algorithms that I've decided to use is soft actor critic and TD3. So first, one of their key differences is in how they go about exploration. SAC uses an entropy term. Basically, remember how I said the actor network just outputs probabilities? It applies a set of randomness on those probabilities, so different actions get taken, and that encourages exploration. Meanwhile, in TD3, it does not explicitly include that. However, it adds a layer of noise onto all of its outputs, so that kind of does the same thing in terms of exploration. So it's two different methods to do. So next is their critic networks differences. So soft actor critic uses a single critic network, and it uses basic Q-value learning there. However, TD3 uses 3 critic networks, and it employs something called double Q learning, which effectively takes the minimum of the Q values and updates itself accordingly. And this is all done to address an overestimation bias. Basically, we don't want to take too far of a step descent, and we caught ourselves in a local minima, and we're not able to find a global minima, basically. And then lastly, SAC, so it updates itself basically at every time step. Meanwhile, TD3 introduces a delay. That's why it's called twin delayed. It adds a delay also to help for the same overestimation bias that we saw earlier. So for both of these algorithms, I found that it took around 100,000 iterations for it to reach the first corner, and then we found a couple of problems. And we'll go into this in the next section, which is the conclusions. Let's just take a look at why it doesn't look too great. So here's TD3 on 70K iterations. Here we could see the steering wheel, relatively smooth, but adds a lot of jitters in it. Kind of freaks out. But it kind of stays towards the center of the track, a little bit off to the left from the geometric ideal line, which is great. It shows that it's, trying to reduce distance. However, we hit that first corner and then we're veering off to the left into the wall. There's a lot of issues and potential solutions to fix this. We just saw that it wants to go straight. And this says to me that there's an overfitting issue going on. I just said it takes over 100,000 iterations just for it to figure out the straight line, right? And this can be solved in a variety of different ways. First of which is to start with a variety of random starting points, right? However, due to how the game works, and it's really frustrating, is I don't have access to the game files, which actually handles all the spawning mechanics. So what it'll do is it'll spawn you in the same spot every time. Now, a way around this would to be input a series of inputs to get to a random starting point. However, doing this in a consistent fashion is pretty difficult just because there's small inconsistencies in the simulation every time you start it up, and that causes a ton of issues. Another solution is to brute force it. Right now, the max iterations I can do is 1 million iterations. However, when I hit around that 100,000 mark, it took around 5 hours, not 500 hours. 5 hours, and then it didn't seem like it was making any more progress past that. So I waited until 150, and it really was doing the same thing. So this screams hyperparameter issue, right? Where we've fallen to the issue of the local optima, the overestimation bias. And this will require a lot of time to figure out, especially in hyperparameters. So the situation just takes a lot of trial and error, I guess. I've also tried automatic hyperparameter tuning using Optuna. If any of you are familiar with that, it's just a framework to get that figured out. However, I wasn't really getting any meaningful results out of that either. So what about multiple environments, right? And that was a great point. I mentioned how an AI racer can use multiple environments. However, I'm limited by my machine here. My computer can only handle one instance of the game before instability really kicks in. When 2 instances are running, the game crashes or I drop frames and states don't get updated in time. So it's not possible with the framework. So maybe I should have done a little bit more due diligence and chose a different simulator. Something like rFactor 2 is another big simulator. However, I think just for the ease of programming, it wasn't, because rFactor 2 doesn't support Python, it would have been a little harder to get all the data out of that simulator. But I'm very much open to questions or tips, or if any of you have ever done something like this, please contact me. The code is available on GitHub at this link here. Feel free to create an issue request or something, and we could talk about how to fix it there. And I'll get around to publishing setup instructions to get this code working soon. But thank you very much, and I hope you guys have a great day.